Hi, welcome to DIY Caddy. If you're here because you're having trouble removing a fastener in your car, you've come to the right place. DIY Caddy is not a typical how-to channel. YouTube certainly has no shortage of those. I'm a DIYer who has done dozens of car repairs over the past several years, and the goal of this channel is to provide helpful insights to save other DIYers time, effort, and money. A word of caution, though. Doing car repairs is not for everyone, so think hard before you take on a project. Remember that any repair you do is done at your own risk. In this video, I reference many tools I found to be helpful, but I don't endorse any specific ones. Also, the prices mentioned in this video are approximates as of April 2025, and they should only be used as reference. I mostly focus on lower-end tools that have worked for me. As a DIYer, I buy tools that meet my needs, not the best tools available. Premium tools may last a lifetime, but they often cost multiple times more. Lower-end tools are cheap, but some come with real issues, so you have to be careful. I encourage you to do your own research for the best options that meet your specific needs. Also remember that some online orders will be subject to shipping fees. I have a lot to say on tools, and I'll try to capture it all in a future video. Before you start working on your car, make sure to take the appropriate safety precautions. Protect yourself, your car, and your work environment. At minimum, wear eye protection, respirator, and gloves. Ensure the workspace is well ventilated and know where your fire extinguisher is at all times. Also, disconnect the car battery to protect its electrical components. Most car repairs require removing and installing fasteners. Although this is usually a routine task, a single stubborn bolt can turn a simple repair into a day-long ordeal. Every fastener you try to remove or reinstall has the potential to be damaged. Fortunately, there are many remedies for these situations. They range from the very simple to those that require expensive tools, such as welding machines or induction heaters. As most amateurs don't own professional-grade tools, this video will focus on the most common methods and tools DIYers use. Car fasteners are commonly made of carbon steel and are manufactured all over the world. They vary in diameter, length, thread pitch, grade, material, finish, and are generally made to two standards, metric and SAE. No matter how or where they're made, though, over time, most exposed fasteners eventually degrade or corrode, which makes removal difficult. For helpful information on fasteners, check out Monster Bolts and Huyet. The general strategy is to first focus on the threads, then extraction, and if necessary, rethreading. The most obvious question I want to address is, why not just use an impact wrench or a breaker bar and just muscle it off? This approach may work sometimes, but it comes with the risk of damaging the fastener and creating a bigger problem. Unfortunately, there's no practical way to know how much force a used fastener can withstand before you actually try to remove it. Therefore, the safest approach is to start small and go bigger in increments. Many times, all it takes is just some lubrication and a hand tool. Other times, you can struggle for hours trying different methods. Note that some removal methods can damage the fastener. And if you're working on parts essential to your car's basic operation, such as brakes, alternator, water pump, you should have replacement fasteners on hand in case you need to get to a local parts store or repair garage. Start by visually inspecting the parts you'll be working on and look for potential issues such as badly deteriorated or hard-to-reach fasteners. Modern car designs often feature jam-packed engine bays, so having enough space to maneuver a ratchet, drill, hammer, or torch may be difficult. Adjacent parts may need to be removed or covered for protection. Also, be sure to use 6-point sockets for hex fasteners, and not 12-point sockets, which tend to strip fasteners easier. Begin by cleaning the fastener with a wire brush to remove rust and other debris. Then apply penetrating lubricant to the threads and gently tap with a hammer to loosen compressed rust. Repeat these steps periodically throughout the process until the fastener has been successfully extracted. I've always used PB Blaster, but there are others that may work well like liquid wrench, or even a homemade mix of ATF fluid and acetone. There's an informative video by Project Farm in which they tested several different products. The very first thing to do is assess how strongly the fastener is seized. Use a wrench or ratchet to nudge the fastener back and forth, clockwise and counterclockwise, just a couple of millimeters each way. Increase the force slightly in each direction and see if there's any movement. Try to coax, not force. Continue to apply lubricant, light hammer taps, and nudge back and forth with minimal force for a couple of minutes. If you still don't feel any movement, you will likely need to move on to extraction tools. If you do sense movement, continue the back and forth with slightly increasing force, light hammer taps, and lubricant. Look for diminishing resistance. Keep in mind that even if it turns initially, it may seize again at a different point on the bolt. So go slowly. Also, if you suddenly don't feel any resistance at all, the bolt could have sheared inside the hole. For a nut-bolt pair, the simplest solution is to just sever either end with a cut-off wheel or saw. Removing a severely corroded or stripped nut without damaging it can be difficult. However, some methods can save the mating bolt or stud. A stripped or corroded nut or bolt head can be difficult to grip with a regular socket. Sometimes locking pliers can work on a bolt head, but avoid using them on a nut. The clamping force could further tighten it onto the bolt. A nut extractor, which is essentially a socket with sharp internal reverse spirals that bite into the sides of the object, is made for both nuts and bolt heads. The spirals are one way, so you won't be able to rock it in both directions. Hammer the correct size extractor tightly onto the object, attach a ratchet to it, and slowly turn counterclockwise. Note that nut extractors can cause permanent damage. If it fails, the next step is a nut splitter. This tool will need a couple of inches all around the nut to fit onto it. Being careful to not damage the bolt, make a deep split on the nut. Make sure this split is accessible so you can place a chisel or thick screwdriver inside it to hammer it in a counterclockwise direction. Continue the process until the nut either releases or peels off the bolt. Nut extractor kits cost around $25 to $30, and a nut splitter costs between $15 and $20. A broken bolt or stud extending above the surface can be difficult to remove without damaging it. With plenty of lubricant where the threads meet, use locking pliers to gently wiggle it back and forth. Try gripping the bolt both with the threads and across the threads. The next method is to use a cutting wheel to slice a straight slot across the top of the bolt and using a flathead screwdriver to turn it. The last method is to use a stud extractor. This tool clamps on directly onto the threads and forces the bolt to turn. If this fails, heat or more intrusive extraction methods may be needed. Typical costs for stud extractors run between $15 to $25. Check out Boundless built and live free videos on how to use this tool. A torch is one of the more effective tools for extracting a fastener. However, this is very dangerous, and I would not recommend it unless you are an experienced user. Not only is there a real risk of fire, it can cause bodily injury or damage surrounding parts. It's especially important to take all necessary safety measures before firing up a torch. The simple theory is that metal expands when heated and contracts when cooled, and repeating this process several times will loosen contaminants and compressed rust wedged in the threads. Lubricate threads in between heat applications and gently tap with a hammer. Be careful if surrounding parts are made of soft materials like aluminum, as they can melt. Keep in mind that heating carbon steel to a very high temperature could compromise its integrity, and therefore reusing these fasteners is not recommended. There's a good video by 1A Auto that shows how it's done. Most DIYers will use two types of gases, propane and MAP Pro. You will also need a trigger torch. Bernzomatic seems to be the most prominent brand for home use. A propane kit goes for about $25 and a MAP Pro kit for about $60 to $70. Their maximum flame temperatures are similar, but MAP Pro will burn somewhat hotter and faster. An upgrade alternative that burns significantly hotter is a kit from MAP Pro and Oxygen, which can also be used for brazing, welding, and metal cutting. The cost for this type of kit is around $75. Professional mechanics mostly use a mixture of oxygen and acetylene. Proper kits will cost over $200. I've personally used only propane for my needs with no issues. Some users say the quality of the nozzle, especially in how it mixes in atmospheric air, seems to be an important factor. A very effective tool that I will just mention here is a welding machine. The main idea behind it is to weld an object such as a nut or any piece of metal and leverage it to spin the broken bolt out with a hand tool. This technique can also work for bolts that are broken below the base. The issue is that most DIYers don't own welding machines, and developing the skills to use it won't happen overnight. Also, although the price of home welders are down to the $100 to $150 level, there's a pretty substantial list of related items you must buy up front, such as a helmet, gloves, welding wire or stick, and possibly a welding table. The total outlay could end up being well over $300. A widely used tool for removing severed bolts at or below the base is a screw extractor, also known as EZ out. The process consists of drilling a hole into the broken bolt lengthwise from the top, then inserting the corresponding extractor inside it. Secure it by tapping the head with a hammer, and turn counterclockwise with a wrench or locking pliers. The size of the drill bit is designed to be just large enough to fit the extractor, and its reverse spiral flutes grab the inside of the bolt as it turns. Some additional key points for this tool. Use a center punch to mark the exact middle of the bolt before drilling. Use cutting fluid to protect the drill bits from overheating, and drill both perpendicularly and straight. If possible, use left-hand drill bits to prevent the bolt from tightening further as you drill. Be very careful not to break the extractor inside the hole. Tools such as screw extractors are made of hardened steel. If it breaks inside the hole and is stuck, you may need special drill bits, or will possibly have to send the whole thing to a machine shop. You can pick up a set of screw extractors for around $15 to $25. South Main Auto posted a video that will give you a good feel for using a screw extractor. If screw extractors didn't work for you, the last option is to rethread. Continue to drill as much of the bolt away from the inside while preserving the threads on the bolt hole. Continue to enlarge the hole using increasingly larger drill bits until you've used the bit for the correct tap size that matches the original bolt. Then use the appropriate tap to create new threads. Inspect them closely, looking for any metal strands or continuity breaks in the threads. If either exists, the threads are likely unusable. However, if the new threads are clean, test them by screwing the replacement bolt into the hole and tighten with light to moderate force. Remove the bolt and reinspect the threads and look for defects. If the threads are compromised, the options are to either tap new standard threads for a larger size bolt or tap new threads for a coil insert for the original size bolt. Note that when tapping in a soft material like aluminum, using a coil insert will result in stronger threads than the original ones. A standard tap drill bit size chart can be found from P&A Engineering Supplies. For rethreading, Eric the Car Guy has two very good videos on the topic, one for a standard rethread and one for a coil insert. A bare-bones tap wrench set, which comes with a few tap sizes, costs around $15 to $20. A full tap and die kit can cost $25 to $200 or more. Most helical coil kits come with a drill bit, a tap, a coil inserter, and coils for a given diameter. Many kits will also include a tang breaker and pre-winder tool. A tang is the little piece at the bottom of the coil that keeps it from spinning on the inserter. You can also use a screwdriver and hammer to break it from the coil. Then expel it from the hole with an air gun or blower. There are also kits that use tangless coils. A pre-winder is a tool used to screw the coil onto it before transferring it into the hole. There are two types of taps, screw thread insert taps, or STI taps, and standard taps, which are not for coil inserts. For a given bolt size, the corresponding STI tap will be larger than a standard tap in order to accommodate the coil insert, which then accommodates the bolt. A standard tap directly accommodates the bolt. Therefore, the drill bit for the STI tap will be larger. An STI tap drill bit size chart can be found from Stanley Engineering Fastening. Although coils and drill bits can be purchased separately, I recommend all-in-one kits to ensure they're all compatible. Rethreading a bolt hole is not particularly difficult, but it does require patience and steady hands when drilling. While tapping threads, make sure to continuously back off after every turn and keep the bolt hole and tap flutes clean. Also, be aware that helical coil inserts compress as they're screwed into the hole. After inserting the coil, remember to remove the tang. So once it's in, at some point, it may not be easy to back it out. When it comes to helical coil inserts, Heli-Coil and EZ-Coil are considered premium brands. Single-size kits run around $25, and kits that include 5 sizes cost around $30 to $35. One important step that's often skipped is cleaning and conditioning threads before reinstallation. Installing fasteners with damaged threads or threads that contain debris or rust particles can lead to problems. Use a wire wheel or a steel bore brush on all bolts, nuts, and bolt holes. Clean with a degreaser. Soak in rust remover. And if possible, clean and restore threads with a thread chaser kit. Once the fasteners are ready to go, soak them in ATF or any other type of oil for an hour or two to prevent corrosion until you're ready to install them. This process won't parkerize the fasteners, but it'll prevent rust over time and help torque the bolts accurately. There are a couple of good instructional videos I recommend from Haggerty and Greg Distributors. One word of caution is that a reconditioned bolt may look like it's in good condition, but if it's been severely stressed, exposed to extreme heat, or has been in service for many years, there's a chance that it's been weakened and should be replaced. Thread chaser kits come in various sizes and run between $25 and $75. OEM versus aftermarket car parts. A great topic for DIYers. For fasteners, like most car parts, a frequently asked question is whether to buy OEM or aftermarket products. Here's what I do. If I just need a few pieces, I get them at the local dealership. They do cost more, but they are exact replacements. I don't need to spend time researching, and the total amount won't break the bank. For larger purchases, I look for aftermarket options. Most car makers' online catalog will list fastener specifications such as diameter, length, and thread pitch, which can be used to search online for aftermarket alternatives. So where do I buy my aftermarket fasteners? I've purchased them from auto parts stores, eBay, Amazon, Home Depot, Lowe's, and online stores like Bolt Depot. After buying hundreds of fasteners, I've concluded that, for the most part, they don't need to be OEM. Auto parts stores like AutoZone, Advance Auto Parts, and O'Reilly's offer relatively good quality products at slightly lower prices. Small online sellers on Amazon or eBay will be the most economical. However, replacements for fasteners that operate under high stress or are critical to the car's operation or safety should be carefully scrutinized. First, make sure the specs match. Don't rely on the photos they provide on the product listing, as some sellers often use stock photos that are different from the real product. Second, make sure the product has a large number of positive reviews, more than just a few dozen. Look through the reviews focusing on the product's quality. Buyers often leave negative reviews for other issues such as long shipping times and poor customer service. While these things shouldn't be ignored, what you're really after here is an assessment of the product. However, if a seller has a very large number of other complaints, be sure to factor that in too. Third, make sure the seller has a substantial number of positive reviews. Again, more than just a few dozen. When looking through the reviews, focus on the negative reviews so you can see whether there are any significant issues that stand out. Also, if a seller doesn't provide enough information on the product listing, just move on. In the worst case, you may have to pay more and turn to a dealer. My final comments to wrap up this video. Faltering car fasteners should not surprise anyone. Think of the conditions they endure. Like everything else, they're not indestructible, and it's just a matter of time before they fail. They stretch, compress, deteriorate, and sometimes even break. I've removed and reinstalled hundreds of fasteners, and they can break at any time during a repair. You just never know. There have been two related incidents that I'd like to share. One happened over a year ago after I replaced brake rotors and pads on all four wheels of my Tucson. I remounted all four wheels and torqued the lug nuts to spec, and I was a very happy camper. A couple of days later, while I was driving around town, I noticed a slight noise that seemed to come and go. Knowing the brakes were the only things I touched, I wanted to check whether I had done something wrong. As I was taking off the lug nuts, I had a feeling they were coming off just a little too easily. It turns out one or two lug nuts on every wheel weren't on as tightly as they should have been. So I retorqued every nut to spec and added about a 1/8 turn. The noise went away, and I haven't had any problems since. Since then, after removing and reinstalling tires, I retorqued them after about 50 miles of driving. The second incident was on my Wrangler. I had just finished major engine work that took months. One of the issues I worked on was oil leaks in several places, including the oil pan. I replaced every gasket and verified there were no leaks, and again, I was a very happy camper. Several weeks later, I noticed a few small drops of oil under the car, and it looked like it was right under the oil pan. You can imagine my disappointment. When I got under the car, I saw that the leak was actually coming from a part called the power plant bending collar, which sits next to the oil pan and is retained by 5 large bolts. Now I know for sure I torqued them to spec, as I did with almost every fastener I installed. So I retorqued them to spec and again added about a 1/8 turn. And it's been good since, so what's my point? My point is that fasteners and whatever they mate with all eventually age. The torque value for a given fastener is determined by its material properties, design, and application. The amount of torque applied to a fastener translates to the clamping force required in the design. Especially for older vehicles, thread damage, corrosion, and other factors can affect the amount of torque needed to achieve the required clamping force. Replacing the old bolt with a new one still leaves the old threads in the bolt hole or nut. So this is why I do my best to prepare replacement fasteners before I begin repairs, and always add about a 1/8 turn to torque spec values. Adding anti-seize and thread locker to the mix further complicates the equation. Thanks for watching. Don't forget to look in the comments section for links to the resources mentioned in this video. I'll be posting a steady stream of videos that cover many other common DIY topics. Also, I'm preparing a website, DIYcaddy.com to make it easier for you to get the information you're looking for. It should be up and running soon. Lastly, if this video was helpful, please like and subscribe.